Hello guys, this playlist will be totally dedicated to Turtle, which is absolutely magnificent Python module that will help you to understand movement and angles and coordinate systems, something that will help you a little bit later when you start with your own games. Right, the shapes will be relatively simple, but of course if you know a little bit about mathematical formulas and stuff, you can create wonders. Right, don't worry, there will be no too much mathematics here, just a couple of stuff, and you can randomize pretty much a lot of movement. Anyway, you're probably wondering, okay, here you see some kind of sun. Well, what else can I do with Python? Well, if you press Ctrl F in official Python, Turtle documentation, and if you search for demo on this page, you will see here one line, Python M Turtle demo. So with that line in your terminal, console, DOS, whatever you have, when you run that thing, you will activate around 20 or something examples, graphical interface. So let's do that. I'm gonna type, because I'm on Windows, CMD to get into DOS, or call it whatever you like, and I'm gonna type exactly that from documentation, Python M Turtle demo. Python M Turtle demo, and we're gonna get into Tkinter pretty much here, because to work with Turtle you need to have installed Tkinter with Python installation, and you probably have that by default. Right, so what about examples? Do you need to type anything here? Well, no. Click here on examples and choose something to see what's up. Byte design, what's that? Okay, bunch of code, you don't need to understand it right now. Let's click on start, and there you go, very awesome stuff. So let's click that a couple of times, and because source code is not changed, you have the same shape, but that's fine, that's cool. Let's see what else we have. Chaos, so let's run it. There you go guys, very awesome stuff, but also wait for the next pass, because this is about chaos example. See, everything is fine, but at the end you will see a little bit of like difference. So chaos is about difference as time passes, and that's pretty much very awesome field of research, pretty much. I really like that. Okay, what about other things like clock? Let's run that. There you go. What about fractals? Some people will love that. Try to do this in JavaScript. Yeah, right. And paint. We can paint pretty much. Right. So how to activate? Oh, right. You need to click on it, and then you roll all over the place. And there you go. You can have something like MS Paint through Python. Well, at least minimal version. And yeah. Rosette, what's that? Wow, beautiful. And sorting animation, start, you know, bubble sort and all kind of sorts. So press S for selection sort, and there you go, you have Turtle pretty much working. So now you know that you can create pretty much complicated stuff a little bit later when you learn how to do it. Nothing special here, it just need time investment pretty much, so don't be scared. Right, so let's get out from here and let's understand the coordinate system, because Turtle is pretty much everything about coordinate system, and you probably know this from high school, primary school, whatever. Right, so let's import that module and let's understand coordinate system and what to do with that. So import Turtle, and now that's not enough, because if you run this stuff, well, at least I'm in idle, so I'm gonna press F5, pretty much nothing's gonna happen because we have just module here. So now we need to create our first Turtle somewhere on a screen. Okay guys, let's give it some kind of name like T, and whatever you use here, it's really not important. It is just abstract name for your first Turtle, and it is important that you are consistent down there through the code when you change characteristics of that Turtle. So T here and T all over the place down there. So let's initialize that Turtle with the name T by saying Turtle module and uppercase T, Turtle, and don't forget brackets. And this is initialization of your own first Turtle with the name T. So let's confirm that. We're gonna save and run our module, which is basically two-line script. And there you go guys, very simple arrow in the middle of the screen. Well, why arrow? Well, it's default. Okay, I don't know why they're using arrow, but it's like that. So don't worry about that, because over time you're gonna learn how to change color of that thing, position, of course, we're gonna do all kind of shapes, how to change size of that, and how to change shape of that thing, because right now we have arrows, but over time you're gonna learn how to use many other shapes and sizes and stuff like that. So the whole purpose, well, let me run that again. The whole purpose of this tutorial is to understand coordinate system, to understand positions, because see here, this middle of the screen is actually 0, 0 in coordinate system. So just imagine that here you have x line and here you have y line, you know, classical mathematical stuff, and cross of that lines is just the start of coordinate system. So 0, 0. So when you go to right, we're talking about +1, +2, +3. On x line, when we are talking about negative numbers, then we have -1, -2, -3. Basically, you're going to left. And also same stuff for y line. Like here, you're gonna have +1, +2, +3. And then down there -1, -2, and blah blah blah. And actually you know that probably from mathematical classes. So same stuff like here. Now in some programming languages, in some modules, and in CSS, I think the start of coordinate system when you are doing all kind of shapes and stuff is here at the top left corner, but this is Python, this is Turtle module, and here we start from 0.0 from here. Right, so objective in this tutorial will be to move that thing all over the place using coordinate system, using positions. Now sure, over time we're gonna learn how to change that thing through movement, like go to right for 200 pixels, but it is better idea to grasp movement through coordinates. Like first we're gonna put our turtle here and then here, and those lines will be connected. So here, here, down there, and back again, and then we're gonna paint that imaginary box that we have like imagined right now. Right, so let's do that. Let's move turtle right here. Okay, the first thing, I need to close this. Okay, so how to move? Well, you're gonna target your first turtle and then you're gonna say go to. Why go to? Because it is in documentation actually, and actually there are some other commands that will yield you same results, like set pos or set position. You can use these things, but go to is a little bit like short, so it's very easy thing to remember, and it's logical, and it is short. So I will use go to, and you can use also these things. Right, so go to, but go to where? Well, go to like 300 pixels on a x line, and also 300 pixels on y line. Basically, if you look into this system, we're gonna first roll here, and then we will roll from 0 to here, and then cross of those lines will be around here. Okay, so I'm talking about wiki page, so it's kind of stupid, but in reality that's what we are going to get in a turtle through Tkinter, right? So something like here. So let's run that, run our module, and there you go, we have movement to that position. Right, so now we need to push that thing through coordinates, just by stating coordinates. So we are not calculating anything, we're gonna push that thing here. And here, if we look into coordinate system, in the center of it, we're gonna have -300 for x and +300 for y, that dot here. Okay, so let's do that. And again, we need to target t, and then go to what I said, -300 for x and +300 for y. Let me fix this a bit like that. Okay, so let's run that thing. There you go. So please note, we don't care about size of this line. We really don't care about that. The only thing we care is 0, 0, 300, 300, and so on and so on. We care about coordinates, about positions, guys, and not about length of lines. We're gonna learn about that too. Right, so let's go down there. T dot go to, and let me use this as a help. So let's say down there will be like minus 300 by x, and also minus 300 by epsilon. Now they are using here minus 1, minus 2, minus 3, but I just think in hundreds, like in pixels, who cares? Right, so minus 3 or minus 300 and minus 300 for epsilon. Okay, like that, and let me run that. Okay, that's cool, and again we don't care about the length of this, we just care about positions. So now we need to find ourselves here and then back here. That means t will go to, let me see, plus x, so plus 300 will be here, and also minus 300 will be down there. So when you cross that thing, the dot will be here, I mean turtle, when you interchange those like coordinates. So what I said, plus 300 for x, and for epsilon that is negative, that is minus, so minus 300, and let me test that. Okay, fine, and now we need to fire arrow to this thing, which is basically beginning, which is plus 300, because it is in first quadrant, this green coordinates. Okay, so of course we have 4 quadrants. Right, what I was talking about. Right, so t go to and plus 300 by x and plus 300 by epsilon. So let me run that. Okay, very cool stuff. And now you're probably wondering, okay, that's kind of nice, but how I'm going to hide this turtle when I'm done? Is there any command to do that? Well, sure. It is, if I remember correctly, hide turtle. Yeah, let me check. Hide turtle. Sure, we can use that to make the turtle invisible. Always use documentation if you're not sure. And actually Google is full of examples, so don't worry about. So t is a target again, but we are not talking about coordinates, we are just hiding that poor thing. So hide turtle and run module, and when we are done, the turtle will disappear. Awesome. Okay, so how we can fill this with some kind of color, like light gray or green, or who cares? Well, can we do that? Sure. So let's define our color of interest, and up here you must do that, because yeah, these are just coordinates, but if you want to fill that thing, then first you need to state color. So the target will be again t, and the color, and let me see, like a light green. Did I type that correctly? Right. But right now, if you run this stuff, well, pretty much you will just get the line light green, but that's not enough. You need to fill that space to remove this this starting movement. So now we need to use fill of those coordinates, of shape between those coordinates. So we need to start that thing here and end it down there. So this is just, guys, preparation. If you have preparation, that doesn't mean that you will fill that shape. This is just for a line, but now we are going to fill that shape. So t dot how, well, begin fill, and now you don't need to state any kind of perimeters here, because already you have color right here. But is that enough? Well, no. Let me actually test that. It's not enough. And now we need to close operations of filling down there. So t.end fill, and now the thing will completely work. Hopefully. There you go, guys. Awesome. So now you know how to work with coordinates and how to fill that shape and how to remove turtle. And let me actually change that to some, I don't know, like other color. This is kind of ugly, like full green or let's say red. Okay, let me run that. Okay, cool. And what is interesting here? Right, so let's create yet another turtle and let's fill that shape with some other color. Sure, we can do that. It's a very easy thing. You can do that without looking the rest of the tutorial for practicing purposes. So I will just like steal this, okay, and I'm gonna put it down there, and let's change the name of turtle to like a Z, or well, yeah, Z, who cares? Z, and so on and so on. So of course, if we want to have different shape, I mean smaller box, then we need to change those like coordinates. So let's change that to 2, because this shape will be smaller. And of course, we will change color. Let's say, I don't know, like yellow. This one will be ugly, but it will work. And of course, we're gonna hide turtle. Z turtle. Hopefully everything will be fine. And there you go, guys. You have solution. Cool stuff. It already looks like a beginning of some kind of game. Okay, guys, I think that this tutorial is longer than 10 minutes, so we're gonna see each other in next one when we're gonna talk about movements, like movement to the left, to the right, how to change angles and stuff like that. But we are pretty cool right now because we know how to work with positions. So yeah, in the next one we're gonna achieve same results through basic movements and angles. We will not use positions, just full pixel movements. Right, thank you for watching and see you there. Hello guys, now when we know how to work with coordinates, with positions, basically let's learn how to use full movement. So we do care about pixels, we do care about length of these lines, and we do care about angles. So methods we are going to use are forward, basically push that arrow forward for number of pixels, push it backward and orient that thing right or left, because it's not enough to have like one orientation to move that arrow all over the place. Right. So let's do basically same thing from last tutorial through pure movement. So the first task is to go from here, from 0, 0 up here through full length, through number of pixels. So we don't care about coordinates. Right. Let me clear this stuff, and I'm gonna just have that first turtle. And yeah, so let's run this stuff and see what we're going to do. So see this 0, 0 position. Now we are going to push that thing up here through, I don't know, 200 pixels, let's say, just to see what's up. But to do that, we need to first orient it for 45 degrees. How to do that? Well, we're gonna say t.left, you know, that method, because we are going to left for 45 degrees, and now we will just get orientation. This is not movement yet. See, we have just orientation, like a mortar in battlefield. So now we need to push that thing right here. How? We are going to use forward or FD shortcut. So let's do that. We're going to target T and FD, and then let's push it for, let's say, 200 pixels to see what's up. Okay, we have very quick result, but this is kind of small box. So how to push that thing to 400 pixels? Well, of course, you can type 400 here, but for some reason, some people like increment stuff. So yeah, you can call this operation 2 times and you will basically have 2 steps, but the result will be same. So whatever you like, use that. I'm gonna use like 400 pixels because it's a kind of simpler. There you go. So now what we need to do is orient that thing to left for specific number of degrees. So let's do that. T dot left, obviously. So how much we must put here? Angles, like well, we're gonna have 45. That's a little bit of turn, and then we will have full turn, and that's basically 135, but result will be correct. Okay, so you see, you have orientation. And also, if you're bad with angles, just experiment a little bit. No one is forcing you to have like a perfect shape. So we're just practicing, guys. So you can have addition here, or if you are very quick with numbers, you can just type this and you will get the same result. There you go. Okay, now when we have orientation, let's push that poor thing around here. So if you remember from last tutorial, the length of the box was 300 pixels. So now we need basically, imagine here the double number, like 600 pixels. So let's do that. T.fd stands for forward for 600 pixels. And there you go, that will work. And now again we need to change orientation. So T dot left, but right now we will just say 80. And again you will have orientation. Okay, now some people will say, okay, that's kind of stupid, I always need to put that like 90 degrees here. Do I need to do that? Can I just say, you know, nothing? Well, let me test that. And no, because you need to pass some kind of argument here, right? So we're talking about degrees. You cannot leave it here empty. So yeah, 90 degrees will get the job done. And then when we are done, we will say T forward, obviously, for another length, which is 600 to reach that third coordinate, like dot down there. Okay, and now you can turn left and put 90 degrees, or you can do something stupid that demands thinking. You can say turn right for another amount, like turn right for how much? For 90 degrees. Let me see. 90 degrees and 180. So let me test that I'm probably correct on this. Alright, so that will work. Now, if this is a kind of stupid, if you think that's the case, then, you know, just use turn left for 90 degrees. Turn left for 90 degrees. Whatever you like, you know, you're not pushed here to do anything. There is no code book. Use whatever you like. Right, so let's push that thing for 600 pixels. T forward for 600 pixels, and let's immediately orient that thing again to left for 90 degrees. And let me test that. Okay, that's cool. And let's just close operation here. We're gonna hit this dot through pure movement. How to do that? Well, we're gonna say T dot forward and 600 pixels, and there you go, guys, you have full box. Right, that's cool. And let's hide this turtle like in the last tutorial. We're gonna say T dot hide, oops, hide turtle. Let me check that, F5. Okay, that works. And what about colors for these individual lines? Can we play with that? Well, sure, let's do that. For a first pass, like from here to here, where is first pass? Here, we're gonna say t.color will be, for example, red, and of course that must be string when you use words. So let's do that, and the result will be full red sides, but we just need from here to here. So how to do that? Well, just use another color for next pass. And where is that thing? Here, I think. We're gonna say that next one will be green, and let me test that. Oh, there you go, everything works. And let me change another colors, like where I was, I'm totally lost. FD and left. Oh, right. So here we're gonna say, I don't know, black, and then here we're gonna say navy, for example. And yeah, let me check the result. Okay, I have a little bit of error here, so I need to correct that. Where is that thing? Okay, right here. So now let me think, magenta or something. Is that a color? I think it is. Right, so now we will have that color separation with lines. Of course, I need to run example, because otherwise you will not see results. Oh, right, so that works. Now, how easily fulfill that thing with a specific color? Well, just here say t dot what was it, begin fill, and down there we are going to close that thing with t dot end fill. So let me test that result. And there you go, guys. The last color that is used for lines will be used to fulfill that box. So yeah, this is kind of dirty and there are a lot of colors here. So I'm gonna just, delete this stuff. It's just too much colors on the screen. Right, so last one is a navy, and I'm gonna delete that first one to see will that last one will work. It will. Okay, and there you go, guys. Now make a difference between color for a line that is black now by default because we don't have it here, and between that and between color of that space that we have created, so that's a difference. And of course a little bit later we're gonna learn how to work with colors and shapes and sizes and stuff like that, but this is just too much colors if you ask me. Now there is yet another thing I want to talk about, and it is a backward like movement. So when you say t dot forward 100 or 200, that will obviously work. But when you say t backward for 200, you will basically go to beginning with arrow. T dot bk, because that stands for backward. And then if you say 200, you will be at the start again. There you go. And of course you can go more backward, like you can say 400 here, and then you will basically go to minus if you think in terms of coordinate system. And there you go. Now here's a funny thing. You can use negative numbers to change directions. Check this out. If you say bk 400 but with a minus, then basically you will go in opposite direction from backward. You will go forward basically. So check this out. There you go. Basically you have you are totally somewhere out of screen because I use something here. So let me just delete this, and now this back will basically become forward for 400s because we are negating back orientation. I mean length of that line. See, there you go. It's kind of weird, I mean, it's obvious and it's logical, but some people may find that thing confusing. Anyway, very simple experiment. So if you don't like negative numbers, the negative lines, then fine, just use like a normal forward and backward and right and left. Okay guys, that's pretty much it in this tutorial. I don't know what I'm gonna talk about in the next one, but probably it will be funny. So as always, thank you for watching, and see you next one. Hello guys, see this code from the last tutorial? It's a little bit of mess, it's too manual, so let's use very simple for loop to create that box. Right, so I'm gonna clear everything here because I don't want to confuse you, and let's create for loop. And if you don't know what that is, well, you have 40 tutorials on basic Python on my channel, and also more than 100 dedicated Python examples in dedicated playlist. Anyway, for x in range 4, because we have 4 sides of box, obviously we're gonna issue dedicated commands, and we are operating on our own first turtle, like default one. So we're gonna push that array, I mean not array but arrow, for example for 200 pixels, and then we're gonna turn left for 90 degrees, like a left 90 degrees, and the result will be, there you go, something like that. But it's very easy, you don't need to type a lot of things here manually. Okay, so let's do something funny here. Let's, for every pass, higher up by 1% that angle. Can we do that? Well, sure, there are a couple of ways, because with that we're gonna have like a rotating box, something like that. So we're gonna multiply angle with 1%, let's say, and let me see what the result will be. Okay, we have something. And how to see better that change? Well, we're gonna just use like a 400 lines, like sides. So let's do that right here, 400 sides, and there you go, you have something is happening. But guys, this is kinda nice but also slow, so question is how to speed our arrow. Well, let's do that. Here we're gonna say t dot speed, and now we need to pass 0 as a value, because if you read documentation, when you put 0 here, the turtle will be fastest. And also you can choose other options, like from 0 to 10. Don't use anything else, use just 0 to 10, and you can experiment a little bit. So now our turtle will be extremely fast. So F5, and how awesome is that? And this is kind of very small circle now, but circle through box, through rotating box, let's say. So let's hire this like a size of imaginary sides. I'm gonna say 400 here to see what's up. F5, and there you go. It's kinda nice. Okay. Cool stuff, bro. Well, let me think what else we can do this. Well, let's experiment with color, let's say. I'm gonna say color will be t.color will be red. And here we're gonna start filling. Well, here, why not? T.begin fill, and you know this from the last couple of tutorials. And we're gonna end down there with t.end fill. Oops, what I'm doing here. And result will probably be weird. I don't know what will happen basically. Okay, that's cool. All right, we have red color. And probably when we pass that 400 iterations, then I need to hide that turtle. All right, so yeah, we have filled everything through begin and end fill. So that's kind of weird and also nice in the same time. So let me see. Right, let's boost these percents, like 5%. Will that change anything? And I'm gonna lower this to 300 passes. And what else? Well, yeah, we can hide turtle, like t dot hide turtle at the end, and save an F5. And there you go, you have like bigger difference now, but result is also kinda nice. Okay, cool. Right, there you go. It's a little bit weird. It looks like it's moving, well, at least for me, when you stare too much at these shapes and these small arrows. So if you want to have like bigger teeth here, well, probably we need bigger percents, like 15%. And let's lower down the number of iterations. Right, F5. Okay, cool. Nice. Come on, come on. Right, but maybe this fill is just too much, so I'm gonna delete it to see what's up. Okay, maybe you can use this in a school for some kind of project, I don't know. I really like it. Anyway, let me see what next. Right, so let's change this percent to be like constant outside the for loop, because it's very stupid to type that thing manually here. So let's say that percent constant is like 1.2, which means we're gonna boost passes for 20%. And now let's substitute this hard-coded value with PC, percent constant, let's say, or Z, or call it whatever you like. And now result will be that. Well, pretty much nothing, because I'm using a very big percents here. So maybe I need to use something smaller, like 5%. Okay, there you go, we have something that looks like a rotation. Right. Okay guys, let's save this code if you need it a little bit later. We're gonna put it into comment section, let's say, and let's create a circle. We have dedicated method for circle. Now we need to say t, because that's our turtle, I mean arrow, and circle. And let's give it a radius like 60, F5, and there you go, that was done very quickly. So let's put this out of service with a comment, and now the things will be slower. There you go, very cool stuff. And what's gonna happen if you have a couple of these with the same radius? Well, pretty much it will just look like a moon. Right, now let's boost that thing. For example, this one will be 30 and 120 and I don't know, 240. So what's gonna happen then? There you go, cool stuff. Like a solar system or something like that. Well, nice. So let me see, we're gonna work with colors a little bit. Here we're gonna say T color will be red for first pass, and then after that we will have like green. So basically you know what I'm talking about here. The lines will be different, and here and also here. Let me fix this a little bit. So this one will be navy, and this one will be magenta, or how to say that in English, magenta, I don't know. Right, so F5, and there you go. Okay, let me see full result here. Nice. So now let's, I don't know, let's boost the speed. F5, and there you go, it's done in a blink of an eye, as they say. Right, maybe that's just too fast. So right, let's fill those areas with some color, let's say red. and I'm gonna finish, or no, I'm gonna finish here. T dot begin fill. I always mix that underscore for some reason. Fill, and I'm gonna end here. T dot end fill. And let me actually check the first one. Okay. So now we can fulfill all other areas. No problem. I'm gonna copy paste this down there, and also there are automatic ways how to do this, but let's just practice with this manually to fully grasp how to do that, and then it's easy to transfer that into like automatic for each for loop solution. It's a little bit confusing, but if you separate your code like that, maybe the things will be obvious. And let's also lower down this last radius. Maybe that's too much. F5, and there you go, guys. Basically we are removing that previous color. Maybe this will be useful for some project for you. Right, what's next? What about dot? Because now we can create dot through circle, but there are dedicated methods for dot. You'll just say t dot, and then let's pass it color, or no, radius, sorry, 50 pixels, and then it will be automatically black. Okay, how to change color of that dot? Well, it's very simple. You don't need to fill it because we are using dedicated method for dot. So it is just enough to say t dot color, and then I don't know, red or something like that. So let me run this example, and there you go, guys. Now the speed, right? So the speed will not be too much important in this case. We can say 1 here, which means slowest. Well, will that influence too much this example? Well, no, because this is like default instantiation creation of dot. We are basically not doing too much with that. We don't have any kind of movement here. But if you say TFD, we are moving that thing to, let's say, 200 pixels, then F5, and basically we are not moving dot, we are moving the turtle that is inside a dot. So this looks like a, I don't know, some kind of vector or something. So let's create an example where we are shooting like vectors from that originator, that coordinate system, let's say. So let me see what I can do here. We can say t dot back 200 pixels, so we are at the start again, and then we will change direction for 45 degrees, and yeah, I can basically copy paste this couple of times and F5, and probably I will have those arrows all over the place, right? Okay, but that's not enough. I need more of those things, so let's use for loop to achieve more shootings, like for x in range, I don't know, 200. We're gonna say exactly that. This will be one line and third line, so basically we don't need those things down there because these things are manual. So now we have automatic solution, and let me increment speed to 0, which means fastest shooting from center of a screen. Right, F5, and oh, there you go. Right, and it will roll and roll and roll until we are satisfied with number of passes. Right, there you go. So you can experiment a lot. Anyway, guys, thank you for watching this tutorial, and as always, see you next one. Hello guys, let's upgrade our knowledge of turtle. So here's the thing, here's a question, how to set background color for whole application. Please note that we don't have any kind of turtle right now, so we are just talking about general background color. How to do that? Well, we're gonna say turtle, and then we're gonna say background color, and obviously we need to pass it some kind of value, like light, gray, or green, it's kinda better. Light green, and I always forget that T. Something is happening with my keyboard, but let's save and run this code. And there you go, you have neutral light green color. So the question is, what's gonna happen if you issue a couple of these commands? Like, what will have priority? This one will be, let's say, red, and that one will be yellow. So what will have priority here? Well, F5. And the last operation, last instruction will have priority. So there you go guys, you have yellow color for a background. So now when we know how to work with a background, very easy thing, almost like HTML and CSS, let's talk about title for application, because default is Python turtle graphic. So we don't like, for some reason, that default stuff, and let's change that into something custom. Please note, no turtles yet on the screen. So what we need to say is turtle, and then dot, and then title, and we're gonna say custom turtle title. Whatever you wanna type here, like blah blah blah, it's really not important. It's just important to use title method. So save and F5, and there you go guys, that's how you change title. Right, now when we know that, let me fix this a bit. Let me see what is interesting here. Well, let's change default shape of arrow into something else. Well, we will still have arrow, but we're gonna change size of it. So first, of course, we need to create turtle, and turtle again without any kind of parameters. Let me test that. Okay, cool. So how to change the shape of it, like how that arrow to become bigger? Well, we're gonna use 3 parameters here. T dot method will be shape size. Shape size, let me check, did I type that correctly? Shape size, and 3 parameters. 20 pixels, and again, just to have something on a screen. So F5, and the result will be very big arrow. Now let's change those things, those pixels, those numbers, to see what's gonna change here in reality. So the first parameter, let's have a 5 here, because the change will be obvious. So let's run that example, and there you go guys, when you change first number, where is that thing? Oh, right, I lost it. Right, so the first number corresponds to size from here to here. Okay, so let's have something insane here, like a 50 to confirm that. F5 again. And there you go, you have something like a stealth bomber or something like that, I don't know. We can turn this into games, you know. Right, so what about middle number? What that means? Well, let's go to default here, and here we're gonna change to 5. F5 to run application, and there you go guys. The 5 means the difference between this imaginary dot and that imaginary dot. So it's like a length of array, or a length of symmetry line through array, let's say. It depends how you think about that. So let me confirm that one more, like a 50 to see things obviously. And there you go, it's very big arrow right now. Okay, next parameter, let's push this to default, is a third one. So let's use 5 here, and then the difference will be in sharpness of edges. Okay, so if you really want to have sharp edges for your arrow, then you're gonna probably use 0 here. Okay, there you go, very sharp stuff. Now, here's a question. How to change pen size? Can we do that? Well, sure. We can say t dot pen size, and of course we must give it some kind of value like 5 pixels, but it will be very smart idea to neutralize this line. Okay, to just observe default arrow F5, and well, nothing here because I'm not using any movement, so sorry about that. Like a T forward 50 pixels and F5, and there you go, it's a little bit bigger. So of course you can change that pen size multiple times. No one is forbidding you to do that. So let's actually copy paste this couple of times. And next one will be 10 pixels to see things better, and we're gonna say 15 pixels here, and let me see, the last one will be, let's say, 20. Okay, save and F5, and there you go. That's some kind of bat or something, I don't know, like a baseball stuff. Right, so let's orient that like vertically, and then let's use for loop to create some kind of shape. Why not? So let me see what I can do. First, vertical orientation. Right, so t dot left, and you must pass it like a value, angle 90 degrees, and F5, and there you go, something like a firework. I don't know, you can create it with a couple of lines of code. So let me see what next. Right, fireworks and for loop. Okay, so let me use dot here, or even better circle, like t dot circle, and the radius will be 20, or yeah, 20, and then we're gonna use couple of others, and we're gonna double numbers here. Well, yeah, maybe this will be too much, but maybe 60 and 80. Let me see what's up. F5. Yeah, something like that. Lollipop. I don't know what that actually is. So basically this is just to left side. So how can we, well, t dot right for 90 degrees, and then t dot left for 90 degrees, and t dot right again for 90 degrees. Let me test that. F5, and well, it is very weird firework. Well, it looks like that in reality. Anyway, who cares? So what about colors? Sure. Let's use color here. Like a t dot color will be red, and I'm gonna pass this couple of times down there, like there, actually here, and also here, and also here, and we need to change colors like yellow, and green and navy, and then down there also we can change those things. For firework, let's say, where this is circle, so before circle we can say yellow again, and where is circle? Down there, and also down there. Well, definitely I need a for loop for this, but still we can play manually. Yeah, navy, yellow, and red, and white. Maybe something like that. It's really not important, we're just practicing. So this code is a little bit stupid and long, but let me see with F5 what's gonna happen. Okay, right. Something like that, who cares? Very weird stuff. Anyway guys, let me simplify this example. I'm gonna cancel firework with circles, so up till here, and I'm gonna cancel colors because that's just too much stuff on a screen. So I'm left just with default movement for that baseball stuff. Let me test that one more time. Okay, so let's use for loop to create a box for that, using that baseball bat basically. Let me see what I need to do. Right, orientation will be inside a for loop. So for x in range 4, because we have 4 sides of imaginary box, well, pretty much we're gonna use this code. Yeah, right. And that one and so on and blah blah blah. Right, so save and F5. Right, something like that. Okay guys, that's pretty much it in this tutorial. Nothing special here. You can play around with colors if you're not confused, but this will pretty much get the job done. And if you don't like results, if they are too much confusing, well, then don't play around with pen sizes too much. Just use couple of those, like this one will be default, normal, and this one will be like boosted to 5 pixels. This one will be, well, normal, let's say 1, and that one will be 5 again. So let me see what's up. Yeah, something like that, some weird boxes. So this looks like some kind of maze, something like beginning of Superplex, that old game, maybe. Depends how you think about stuff. Or some plan for the house, I don't know. Weird turtle, weird. Okay guys, that's it in this tutorial. Thank you for watching as always, and see you next one. Hello guys, in this tutorial objective will be to set background image, like a custom background image. That's the one thing. Another thing is how to set custom window size for our application. And also we're gonna play around with other methods and options, but first let me set, let's say, custom window size. So I'm gonna clear airspace pretty much here. I don't want to confuse you and myself. Right, so custom size, custom window size. Well, we're gonna say turtle and then dot and then setup. So everything I'm typing here is in documentation. I'm not inventing anything. So here we need to pass a couple of arguments, parameters, call it whatever you like. And the first is width in pixels, for example 800, and 500 for height. Right, so let's save that and F5. And there you go guys, you have custom width for application. I mean custom dimensions for window size. Okay, so what about other parameters? Well, other parameters that you will state here are starting point for application, because by default we have it in a center of a screen, but maybe for some reason you want to push that application at the upper top corner, let's say. So how to do that? Well, exactly here on that line we're gonna say start x equals 0 and then comma and then other coordinate start epsilon also 0, because now we are not talking about position of turtle, we are talking about position of window of application. So we're gonna have upper left corner of application exactly here in upper left corner of monitor basically. So let me save that and F5, and there you go guys, you have your custom position too. Right, if you want to push that thing for some reason for 100 pixels by x and y, for example around here, let's say you want to say 100 here, and also for y 100, and save and F5, and there you go, you have results. Right, but maybe I'm gonna stay with default position, why not? So I'm gonna delete this. Okay, so also I'm gonna have 800 pixels for height. Let me test that, because right now we're gonna import image. Okay, so image must be of GIF type or GIF. I don't know how you guys pronounce that in English. So just make sure that that image is in the same folder where you have your turtle application. In my case that's turtle fun, and also I have bg img image GIF type in that directory. Right. So how to do that? Well, we're gonna say turtle and bg picture pic, and we're gonna just pass name of that image as a string, of course. So bg img dot gif and save and F5, and there you go, guys, we have our custom background. So if you wanna have your application same size as the size of image, well, the easiest thing is to find out the dimensions of that image. Let me see what I was using for template, for thumbnail. Right, properties, and that is HD. Right, so this dimension 1200 blah 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 and so on. So let's change that right here, like for width and for height, and save, and now we're gonna just have image as a background. There you go, guys, and of course we have rest of the source code working. Okay, let me think about something else here. So the next question is how to get out very politely from application. Like, you don't want to press, X every time when you want to get out. So how to do that? Well, we are introducing a new method here, which is exit on click. Basically, if you click somewhere in application, you will get out. So we're gonna target here the whole turtle like window. So turtle and then dot and then exit on click. And that's of course function or method, call it whatever you like. So you must use these brackets, parentheses, whatever, and F5 to run application. And let me wait for a couple of seconds, and now let's just press here, let's say. Or what's happening? Method turtle has no exit on click. Why is that so? Oh, right. Sorry. Something is happening with my fingers. C-L-I-C-K. Right, click and not click. Well, there you go, guys. Now the thing will work. I'm gonna click here. There you go, everything is fine. So the question is how to get out from application immediately when application is done with main source code, like when operations are done. Well, you will not use exit on click, then you will use by, just by. So we're gonna target turtle again, turtle window, basically the big picture, turtle, and then we're just going to say by. Of course, this is a method, so parentheses and F5, and when this is done, we are off. Right, but what if you wanna introduce pause before exiting application? Well, you can use, for example, time module, because in a time module we have a pause option, like sleep option. So of course we need to use that pause before we get out from application, like here. So module is time and the method is sleep, and we're gonna sleep for, let's say, 5 seconds. So whatever you put here is in seconds. It's not in minutes, it's in seconds. So save and let's run application. And okay, 2, 3, 4, 5. There you go, something like that. But important thing is that now we we know how to work with pause. Okay, let me think what else is interesting here, and actually we can delete this because it's maybe too much things to digest on a screen. So the question is how to delete operations after we are done with them. So we are still in application, but we wanna clear screen, just like in DOS when you type TLS clear whatever. So yep, we can do that by targeting that specific turtle. So we're talking about turtle here, specific one, and not about window, guys. Okay, so t dot clear screen or clear, and let me run that thing, F5, and yeah, so we don't have now that movement of turtle, so that's kind of cool. Okay guys, I think that's enough for one tutorial. A lot of stuff to digest. Just remember, the most important things here are setup of window. Like minimally you need to state width and height, and if you wanna use a background picture, that thing must be of GIF type, right? And of course you don't need to use like a background image if you don't like that for some reason. The white will get the job done pretty much. So F5, and there you go. And now when you resize that thing, you will not see like a green part of screen. Okay guys, as always, thank you for watching, and yeah, see you in next tutorial. Hello guys, in this tutorial we're gonna learn about different shapes for turtle. So we're gonna use t.shape method, and of course we need to pass it some kind of parameters. Well, which one? Here, if we check documentation, we see that we can choose between arrow, turtle, circle, square, triangle, and classic. So actually the default one is a classic one, because now if I pass here like classic, and if I activate that, then nothing's gonna change. So classic is default. But if you want to change this to arrow, you can do that. And arrow is basically a right oriented triangle. So let's do that. Over arrow, and there you go. And if you want to see that better, then we can change shape size. So let's do that. Target is a T, of course, and we're gonna change shape size. And of course, you remember from a couple of last tutorials that we need to pass 3 parameters here, like a 10, 10, and 10, and that thing will be a little bit bigger. Okay, and see these edges here? Well, if you want to have them sharp, as it is case with the default stuff, then just lower this third parameter to 1, let's say, and you will get sharpness better. Okay, next thing, what about turtle, like a real turtle? Well, we're gonna say turtle, and there you go guys, we have it. So most people like that thing better than like a classic or triangle or arrow shape. And don't worry, we're gonna play around with colors, but just let's check those like shapes. Right, so circle, well, you're gonna say circle and F5, and there you go, you have a result. And of course you see these edges and they're kind of sharp, but if you have small circle, then you will not even notice that. And what's gonna happen if I remove this line, if I pull it out from service, then of course that will be default size. Save. And what about square? Well, let's change that. Square, F5, and there you go. And if you want a slight radius here, then you can use 20 here. Let's test that. Or we can use something insane like 70. Let's test that. Well, that's maybe too much. It depends how you like it, okay? Let's stick with the 1, which is kind of sharp. Okay, triangle. Well, triangle, F5, and there you go, you have orientation to right. But there is a difference between classic, because classic have that like here, if you remember. Right, so that's a triangle, and now let's experiment with turtle shape. because it's kinda nice. And let's experiment with colors. So if we say t.color, then we will fulfill border of turtle and inside of turtle, like red, F5, and there you go, guys. So question is how to fill just inside of turtle. Well, there are dedicated methods to do that, and we will not use the color here. And now by default color is black. We'll just say t.new method, which is fill color inside the turtle. And now we're gonna say red and F5, and there you go. And if you want to see that blackness a little bit better, then you're gonna change third parameter and you will see like 10, F5. There you go, guys. Maybe you like that better. Okay, what's next? Right, so how to change this black color? Well, we have dedicated method to do that, which is a pen color. So t.pen color, and let's use yellow, F5, and there you go. Maybe that's not real solution. I don't know, it's too much yellow. Well, right, let me just leave it at that because I'm not good with colors. So the next thing is, what about movement? Well, let's change that. For example, t.left, and then we are going to orient our turtle to 90 degrees, and F5, and that will work. But orientation is kind of fast, so let's slow our turtle. We're gonna say t.speed 0 and 1, and if you check documentation, 1 means slowest, so we will have a slight animation here. There you go, it's the slowest, guys. Oops, my phone is ringing, just a second. Okay, guys, sorry about that. I'm back. Let's push this turtle to like forward. FD for 50, let's say, pixels, and okay, that will work. And maybe the turtle is too big, so let's say 5 here and 1 here, and now we have variable result, let's say. I'm gonna also change pen color to black because it's kind of nicer. I don't like yellow now. Okay, cool. And we have some kind of trail, who cares? Right, so let's change immediately size after this movement. I mean shape. So shape, and sure, you can change shape size too. So shape now will be circle, and let me test that. Okay, cool. And we're gonna use here another forward for, let's say, 70 pixels, and we're gonna change shape again. I don't know how to type these days. Triangle. Let me test that. Okay, cool. And let me, for example, now change the pixelage like 100, and I'm gonna say t.shape again for square, and we're gonna stop there. Square. Let me test that. Okay, so let's turn this into animation, let's say. But before we do that, let's like a change size of thing where well, I'm gonna just copy this, for example, down there, and then down there, and then down there. For example, we have like from 10, let's say, from 10 to 5 to 2. Maybe that will be interesting to see what it is. F5. Right, something like that. And maybe it's even ugly, but yeah, let's delete it. Maybe you are too confused and it's not that beautiful. Okay, what now we can do? Well, we can put this in a for loop to have like animation. So for x in range, and we need, for example, 10 passes, we're gonna use everything here. So let me push that to right, shift and tab, and save, and F5. And there you go, we have animation. So maybe guys, you can change this into some kind of school project, or you can print this. I don't know, it depends. Maybe you like it. Right, so you can turn this into semaphore, horizontal or vertical. Right, that's it in this tutorial, nothing special here. And if you are tired from clicking on X every time, of course, if you remember from a couple of last tutorials, you can say turtle dot exit on click, and don't forget brackets, and then if you click here anywhere, you will get out. You don't need to click on X, but this will last and last and last 10 passes. So maybe that's just too much. Well, I'm gonna remove it, and let's use just 3 passes here. Okay, this will be 1, and this is all right. So it's not full pass, it's just a number of sides. So yeah, maybe I can stick with a 4, of course, 4 sides for full box. And of course I can click anywhere and I will get out from application. From turtle, I mean, it's not application. Now there is another thing. You cannot use this line like in the middle, because you will break your application. That will not work. F5 and problem. So don't do that, because if you use that, all other source code will fail. As you can see, you have a lot of problems here. Okay, so these things are not like executed. Right, so just use that line if you need it at all down there when you are done with operations. Okay, I need to wait and click, and that's it in this tutorial. Thank you for watching, and see you next one. Hello guys, in this tutorial we're gonna play around with loops. So whatever we create with a for loop, we're gonna replicate a result with while loop. So we will get probably same stuff, or at least similar stuff. Right, I'm gonna shoot for same result. Okay guys, so let's have something to work with the for loop. For x in range, and we're gonna start with 0 and end up with 20. So it's just enough to type 20 here. We're gonna create circle like t dot circle with radius, and the radius will be in that range from 0 to 20. So let's just grab this x and put it here, and I'm gonna press F5 to run program, and we have something, but it is very slow and very small, so that's not good. Let's speed it up with t dot speed, and here you can have 0, which means fastest, but generally you can play around with 0 up till 10. Don't use anything else, just 0 up till 10 for speed, guys. Okay, for speed. So let me F5 now. Okay, it's faster, but it is ugly. Right, so let's start with 20, and we're gonna end up with 50, and let me run that stuff. Okay, kinda nice. So this is too packed, so let me boost that radius for 100%, and easiest thing is just to multiply with 2 basically. So F5, there you go, kinda bearable. Right, so let me experiment with direction in a for loop. Why not? To get some kind of complicated shape. We're gonna say t dot left for opposite is 180 degrees, and F5. There you go. It's kinda clear and kinda nice. Okay, so let's experiment with circle in a next pass, like a t dot circle, and also radius will be boosted a little bit, but we're gonna change direction for 45 degrees just to see what's up. Okay, kinda nice, but too much for our eyes. We need something simplified. So left, let's say, and we're gonna turn for 9, how to say this in English? 90? No, 90. Yeah, 90 degrees. F5. Well, that's kinda bearable. It's kinda simple, but not that simple. So guys, let's create a while loop which will yield us that result. But to do that, I need a reference because I cannot remember everything here. So I'm gonna start MS Paint on another monitor, and I'm gonna print screen on my keyboard, and I will pass that image on another monitor. Right, so I have a reference. Let me show that just for in a second. Okay, so this is my paint, and this is just a print screen, obviously. So let me cancel this example, and we're gonna create while loop. Okay, so we must put this in some kind of comment just to have something on a screen if I ever lose a sight of this like an algorithm. And we're gonna say like starting position will be 20 because that's the case right here, and I'm using n. Why not? You can use whatever you like here, something abstract like x, y, z, whatever. And then we're gonna start while n is smaller than, well, 50. We're gonna start with operations, and operations will be pretty much same. So copy paste will get the job done, and let me run this stuff. And nothing happens because, right, x is not defined. Right, so here I'm using n, but down there I'm using previous 6, which is extremely stupid. So I'm gonna just type n here and F5, and we have problem actually because I'm not incrementing here. So how to do that? Well, obviously when you're using while loop, don't forget to increment. You're gonna say that future n will be existing n plus, I don't know, 1, let's say. You can use whatever you like here. So we're gonna start with 20, and then we will roll up till 50, but increments will be 1. So 20, 21, 22, blah 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 until we reach that. Okay, so let me test that, and there you go. We have, I think, same result as we have with the for loop. So let me confirm that with the print screen. Right, so that's pretty much it, guys. Okay, nice. So yeah, let me see what else we can do here. Let's play around with n times, I don't know, like 5% here, and here I'm gonna multiply with I don't know, like 15%. Maybe that will be interesting to see what that thing is. And F5. Okay, kind of weird. And let me change this to 50% for last circle. Well, something similar. Okay, let's play around more. Like I'm gonna have bigger steps, like 5 pixels. Oh, all right. So I need to have more passes. So range need to be bigger, like 300 or 500. Yeah, 500. And F5. And that thing becomes very, very big, but it's kind of beautiful. And it will constantly work up till we reach 500. Imagine to generate some kind of terrain with this, with some planes shooting each other, like all those games. That will be wonderful. Well, I need to learn about that, about game development, but we'll see. Okay, So what else we can do here? Right. So constant loop. So we don't need here any kind of limitation. We're just going to say true. And when you say while true, that thing will constantly be executed. Right, F5. And there you go, we have this thing working constantly. So let me arrange this a little better, if you can see that. Just to see what kind of result we have over time. So yeah, this will end up interesting. But I don't know how much time you have to watch this stuff. Probably not many seconds to spare on this. Anyway, you can play around with a lot of stuff. So let me change color. Right, so here I can change, I don't know, like t dot color will be a red, and then for the next pass, for the next circle, we're gonna have t dot color yellow or magenta. And let me see. Okay, kinda colorish. So you can print screen this and paint on the wall or something like that. Right, and let me create another shapes. We're gonna have very small steps here, but I will just boost that thing with 200%, let's say. F5. Right. So it's a well, yeah, it's definitely symmetrical. It's kind of nice on eyes. Right, guys, that's pretty much it in this tutorial. Do whatever you like with this source code, you know, print it on a screen. I mean, not source code, just shapes, and experiment a lot. Right, I'm gonna end up here, and as always, thank you for watching, and see you next tutorial. Where is my Camtasia? Right here. So, thank you for watching, and see you there. Okay guys, in this tutorial we're gonna move turtle all over the place with keyboard. Right, so I'm gonna import absolutely everything from turtle module, so I will not say this, import turtle, because then I need to type a lot, like turtle do this, turtle do that. But when you say from turtle, import everything, then every method, option, functionality will be automatically activated. So I just need basically to type less. Some people don't like this approach because they will say clashes between the names of methods are possible. Sure, but I'm just using one module here, so no big deal. Okay, so let's create turtle. T equals, and of course now I don't need to say turtle, I just need to say turtle, like uppercase T, and we're gonna have turtle on a screen. Okay, there you go, same stuff like in previous tutorials. Right, so now we need to create 4 functions that will be connected with buttons on your keyboard a little bit later, but functions first. So how to create any kind of functions? Well, def and then function name. And if you don't know what I'm talking about, then you have 40 tutorials for basic Python on my YouTube channel. Right, so F will stand for move turtle forward, basically, and this is a method, so of course brackets, and operation will be FD. You know that, like push turtle forward for specific number of pixels, let's say 20. And also same stuff to move turtle like back, and functionality will be BK. You have that in documentation, but we're gonna use pixels here, so 20 pixels. Exactly same stuff for both of these functions. Okay, that's for forward and back. What about the left and right? So please note, we are not moving turtle horizontally. We are using angles here. We are talking about orientation, guys. Okay, orientation in place. So basically we will have like a rocket turtle, and rockets need orientation in a moment of time. Anyway, let me type what I wanna, well, what I'm thinking. If we wanna turn to left, we're gonna use L function. You can use something else here like TL or something more obvious for you. And when we activate that function, we're gonna turn to left for 20 degrees, right? And same stuff for turning to the right. We're gonna activate our right method in turtle method for turtle module, sorry, for 20 degrees. Okay, so now we have preparation, guys. This is just preparation of functions. So how to detect K presses? Well, we're gonna ask documentation for that. So here, if you wanna detect press, you're gonna use onKey method, and you need to pass two things to that method, like what is a function that will be activated. Oops, just a second. Right, so what is a function that will be activated and when? So you need to connect function with kpress, and kpress are basically hard-coded in module. So let's use onKey, and on the left side you're gonna have function which will be F for forward, and the key will be up. So you must type up exactly like I'm typing it here. And the same stuff for all other directions. For if you want to go backward, you want to activate B, and a hard-coded value from like module will be down. And if you want to go to right, you're going to activate R function if you're going to go right. And if you're going to go left, then L function will be activated if you press left on your keyboard. But let me run that stuff and see what's up. So basically, will that work? Well, no, because now we need to listen for these K presses. And how to do that? Well, you're gonna say listen here, listen, because you have that in documentation. It will basically track what's happening on a turtle screen. So that's like some entity that will watch what you are doing on the screen, and based on that it will activate these like methods. Right, so you don't need to pass any kind of perimeter here. It's just Blanco method, detection method. And now the thing will work. So F5, and there you go, guys, we have turtle, and we can move it when we press keys. So every time when you press key, it will move, but it will not move if you press constantly key. You need to like press it every time when you wanna move. And also it will work to right, and it will work for back. See, but I'm constantly pressing that key. So how to evade that? Well, you have another method which is onKey press. Okay, so you don't need to press a lot if you're using onKey press. So let's substitute onKey method with onKey press, and now the thing will like constantly roll. Well, to some degree. So I'm gonna press once, and see, the arrow will move. And also if I hold the left, it will rotate, and it will go back basically. This is just a turtle thingy. Okay, but important thing is that it will always be activated if you are still holding that K on a keyboard. Right, so this is kind of ugly. We need a bigger, like a symbol, like turtle. So let me see what I can do. Shape size, and now I don't need to specify turtle because I'm importing absolutely everything, and we are working only with one turtle. So shape size, and we need to pass it 3 parameters, if you remember. Okay, and this thing will be bigger now. There you go, guys. So let's rotate it constantly. I'm gonna press L, and it will rotate, and funny stuff, it will go also back, but this is like a classical turtle glitch, as they say in games. But it will constantly roll in that specific direction, and you do have trail. Okay? Right. So it's like some kind of plane or rocket, something like that. So let's see what we can do next. Like, can we change colors when we do different presses? Well, here I'm gonna say, well, before that I'm gonna use different colors, like a color red, and let me test that. And when I'm moving forward, it's red, and also when I'm using other directions, it is red, because it's a kinda only color. But if we change that for every key, for every button, call it whatever you like, if I say blue here, then obviously every time when you use those functions through key presses, then we'll have different trail. Right, red, blue, and what is else? Green, and I don't know, like orange, red, or yeah, orange. Orange. Save and F5, and that will work in one direction. When I rotate, another color, and when I rotate in other direction, another color. How awesome is that? And again, and when I go back, there you go, guys, you can play around in so many ways. How awesome is that? I don't know, for some reason it's going back if I press any key too much for angles, but that's like a turtle stuff. I honestly don't know how to fix this, but basically I'm using too much of key presses. Right, let me see what else. Well, we can experiment with bigger angles, like 45, but maybe that's just too much, you know. 45. And see? Yeah, you'll get weird results. You can experiment with this. Very weird results. It is almost non-functioning properly. So yeah, use something less, like a 10%. I mean 10 pixels for angles. I mean degrees. Right, so 10 degrees and 10 degrees and F5. Right, right, there you go. Okay, guys, that's pretty much it in this tutorial. Nothing special. Just remember, if you wanna activate detection of constant press, use on key press, and if you wanna activate those functions only once when you use press, then use on key. So another option is to use on key release, but rarely you will need that. So basically that thing is the same as on key, but it will be activated when you lift your finger. Right, so that's pretty much it. Okay, guys, thank you for watching as always, and see you next tutorial. Hello guys, in this tutorial we're gonna learn how to move turtle with mouse. To do that, we need to find coordinates of that specific click in that specific turtle screen. To do that, we're gonna use on-screen click method. So let's type that, on screen click, and that method needs another method that will be our own, like a custom one, because yes, we will get with this method coordinates, but now we need to use it, at least for now, to print it. So function, right, our own custom function will be, let's say, get chords. Now here's the thing, you don't need to pass arguments here like that, okay, with x, y here. No, we are just calling, like blanco calling this method. Right, so now we need obviously to create it, and def name will be get chords, let's say, and now we are talking about real parameters x and y coordinates, and those things are provided with this primary turtle method. So this is a custom method and this is a turtle method. See, right here. Right. So now let's just print those coordinates. And then after that we're gonna use it for orientation and movement. So print x, y and f5. And something is happening. Get chords is not defined. Well, how? Oh, right, chord S, sorry, F5. And now the thing will work. So how I know that? Well, let's click here, and there you go, we have coordinates, and when I click all over the place, of course I will target different pixels, and I will get appropriate coordinates of those pixels in this turtle screen. So it is important that we have those coordinates. Now what? Well, now we need to go to those coordinates. Well, let's do that. I'm gonna substitute printing with turtle, and we're gonna use go to, and that's enough for now. And let's test that. F5, and there you go, guys. We have movement with left button on a mouse. But you will say probably, okay, this is kind of small, let's boost that thing. Well, okay, so let's do that. I'm gonna say T shape size, and we're gonna use, if you remember, 3 arguments here, and let me test that now. And there you go, we have something to work with, but we don't have sorry, we don't have orientation. So how to fix this orientation for every pass, every time when we click on a screen? Well, we're gonna use set heading method. Let me find that. So this is a method that will help you to in place orient that arrow. Now make a note, set heading method will be used to set that stuff, but if you want to find position, like heading in a moment of time, I mean angle, then you would just use heading method. Let me find that. Where is that thing? Right. So that heading method, it's right here, will tell you the turtle state, but you need to set first turtle state with set heading. So that's a major difference. Okay, so let's do that. For example, right here, set heading, and we need to pass parameters to it, which is specific angle. Well, how to get that angle? You don't need to do any kind of calculation on your own here. We're gonna use another method which is towards. So let me type that, towards, and this method will return momentarily angle between the line from the turtle position, I mean originator, to position specified by XY. So that's like an angle difference. So we are heading to that angle difference that is the last one, that is the current one. How? Well, we are going to target T because that's object of our interest, and then we're gonna say towards, and of course we're gonna pass those actual coordinates like X and Y. And now when I run this thing, what's gonna happen is, well, pretty much nothing. Why? Because we are calling that method, those methods, when we are done movement, when we are finished. So it's stupid. But first we need to set heading, and then we need to go to. So let me just copy paste this right here before actual movement. So first heading and then movement, and then and not otherwise. So let me save and F5. And there you go, guys, you have now what you need. So let me see what else we can do here. Well, if this is a kind of slow, of course you can play around with speed. You can say T speed will be 0, which means fastest turtle. And let me test that. There you go, guys, extremely quick action, and of course you can set color for that turtle. For example, like a color red, and now the trail will be red, obviously. Right. Now some people will ask, well, what if I do something stupid here? Like, what if I call that famous method exit on click? So we're gonna have clash here between exit on click and actual clicking that will define movement and angle. So let me see what's up. F5, and we have something, but the moment when I click here, I'm gone. So there is no purpose in using exit on click when you are targeting mouse movement. Now there is a hack here if you don't want to think about headings and orientation and statuses and angles. Well, basically you can just change the shape to circle, and that's it, guys. That's very it. So let's do that actually, like a t dot shape circle, and now you don't need to care about angles and orientation. See? There you go. How awesome is that? And of course you can boost sizes, like right, 10, 10 and 10. Right, that will work. Fun stuff. Okay guys, that's pretty much it in this tutorial. Nothing special here. Just remember that if you want to do anything at all in your source code, first you need to grab coordinates with on-screen click, and you need to pass your own custom method that will grab those coordinates, you know, x and y, and then do printing, do movement, whatever you like. But first, this method, turtle method. Right, I'm gonna shut up as always. Thank you for watching, and see you next one. Hello guys, in this tutorial we're gonna learn how to drag turtle with mouse, and code from last tutorial is very nice as a starting point. So immediately I'm gonna change circle to actually turtle because it's kind of interesting, and I'm gonna activate heading and F5 just to test situation. Okay, that's cool, and we have decent speed, so that's fine. Right. So what we need to change here? Well, we are going to use onDrag method. Now that method demands another method, our own custom one. So let's actually type that right here because it's simpler. So the target is a turtle, obviously, and we're gonna say onDrag, and we're gonna pass to that thing function. Well, what kind of function? Well, same function that is outside. So yeah, I know that it's kind of weird because we have internal function calling external function, but that's how we get the job done. So let's just copy paste this down there pretty much. Get coordinates, and we don't need to pass any kind of arguments here because that thing is already done automatically. And how we have those coordinates? Well, through this primary method. So now let's save and run our code, and let's see what's up. Well, we have something, and we can actually grab that stuff and drag it a little bit over the place, but then we run into problem. Why is that so? Because we didn't canceled last movement, like last positions. So how to do that? Well, we're gonna use again onDrag method inside of this general method, but now we're gonna reset stuff, because if you read things down there, bind a function to mouse move events on this turtle. But if function is none, so we are going to provide none to onDrag, then existing bindings are removed. So that's like a reset. So first we're gonna inside have a reset, and then operations, and then again dragging, and over again and over again. So let me type that. T dot drag, onDrag, and the parameter will be pretty much none, because that's what we have in documentation to restart things. None, and now save and F5, and now the things will work fine. So see, there you go, guys. And maybe this turtle is a big, so let me just lower that size, like 5 and 5 and 5. And maybe we'll see things better if we use, for example, well, like a normal speed for turtle. F5, and yeah, there you go. Maybe that's too much aggressive, but you know, the turtle is kind of big, so you will notice those movements a lot. Now you will probably say, well, big deal. Well, it kind of is, because not just that you can drag your turtle, you can also move it with independent clicks. Check this out. See? So basically you have two solutions here. So use whatever you like, basically. Okay, so just make sure that you are kind of resetting for every movement. For every coordinates you're doing reset, and then headings, and you're going there, and then you are grabbing like coordinates again to drag that thing further. Yeah, I know it's kind of confusing to think about that, but if you don't do it like I have here, then you're gonna run into some kind of glitches. I ran into this solution through practice because I was busting my head, but apparently you need to reset position, basically. So for all those people who are first time in this tutorial, we are using on-screen click turtle primary method to grab coordinates, and then we are providing those coordinates to that method that is our own custom one. Here we are, okay, and we are using those coordinates that are provided from here as perimeters. Why? Because we need to go there, okay. So it will be very nice if we have turtle turning around to track our mouse, basically. So we are using set heading method, but that set heading method, and that is in documentation of course, demands like angle. So how to get that angle? Well, we are using towards those existing coordinates from here. So yep, guys, it is a little bit confusing, and if you are confused, then just remove this bunch of stuff and play around with default shape and speed and stuff like that. And I'm gonna also remove, for simplicity reasons, heading, because turtle will work without that. I mean, now I will have arrow, just F5, and see, the thing will work. No like changed heading, but still we have something on a screen, operational. And of course, if you don't like that, then you can say t dot what was it, just a second, my mind is blocked, shape, yeah, shape, then just use, you know, circle, and it will look prettier. Circle, F5, and there you go. So we have movement, independent coordinates, and when we click on that thing, we can also drag it all over the place. So just be slow here, okay, guys? And if you wanna boost that speed, then just, you know, use speed 0. Okay, that's pretty much it. Don't forget to use none to reset stuff, and the last operation in function need to be on drag. Thank you for watching. See you next tutorial. Hello guys, in this tutorial we're gonna create very simple turtle race game with the two turtles. Very simple stuff, don't worry. So we have solid base here. This turtle will be turtle 1, and down there we're gonna change immediately shape of that turtle to be like real turtle and not arrow. So we are going to say T1 shape will be turtle. Turtle is a string. Okay. And now we're gonna clone this turtle. So turtle 2, we will get that thing when we clone turtle 1. Okay, so T1 and clone, and that's actually a method that you can find in documentation. And now if we run this stuff, we're gonna have only one turtle in a screen because we don't have them at different coordinates. So let's push those turtles to initial starting coordinates. Well, we are going to say T1 need to go to, let me think. So we will have them horizontally aligned. So the first turtle will go to minus 300, that will be x, and epsilon will be 0, and turtle 2 will go to plus 300 on x coordinate, and epsilon will be 0. Okay guys, so let me check result. Okay, fine, don't worry too much. Now we need to orient that turtle like vertically. So let's do that. Where we are going to do that? Okay, here. Because we are cloning turtle 1 to be turtle 2, so the changes will propagate automatically basically. So T1 by default we're gonna orient it with the left method for 90 degrees, and that will be replicated on turtle 2. Okay, cool. So this is kinda in the middle of the screen, so let's push this turtle by default totally down there, like a minus 300. Sure, let's do that. Negative 300 in both of these cases, so we are going down basically. If you ever play like MiG-29 game, you know, old Fulcrum, you probably remember that cross when you're targeting other planes, and generally when you're playing that kind of games, you know, you have negative and positive and stuff like that. Anyway, I'm babbling, so this is story about turtle. Okay, now don't worry about these things. We're gonna remove it when we type pen up, so for both of these guys. So T1 pen up before we do that change. So pen up need to go here, guys. Okay, pen up, and this is a method, so brackets, and let me test that. Okay, cool, starting point, and let's change colors of these, and they need to be independent. So T1 color will be, let's say, red, and T2 color will be yellow. Something like that, it's really not important. Yellow. Okay, cool. Now we have something to work with. Okay, so this is like a turtle setup. So let me have some kind of comment here that will differentiate between turtle setup and target setup. So now we need to have circles, let's say, up here, okay, up here, that will represent targets. So when turtle reach that thing, the game is over. Okay, so how to do that? Well, let me think. We're gonna use circles, guys. What is this? I don't know. Alright, so we're gonna have circles, and let me create that thing. I'm gonna call it finish 1. Finish 1 equals, that will be turtle, and we need to go to that direction, to that position to create circle. So let me see, finish 1 is a target, finish 1 is a target, and we need to go to, but what about coordinates? So negative 300 for x and positive 300 to like get in upper part of the screen. Right, so let me actually test, will that work? Well, at least in this first case. Right, so something like that. Don't worry about this line, we're gonna change those things. And let's immediately create a circle for finish 1. Circle 20 pixels, and let me test that. Right, okay, so we need to replicate that for finish 2, but first let me remove this like a arrow. I don't like that. How we are going to do that? Well, finish is a target, of course, and hide turtle in that case, and we can also change, well, color. Well, maybe not, maybe we are complicating too much. So let me check now what's happening. Okay, cool, we don't have that thing, but also we need to remove this line. So how to do that? Well, we will use pen up and pen down methods. So when we start rolling here, we will remove line, and when we reach that thing, then we will activate line again to create this circle. Right, so let me see where I'm going to put that. When I create turtle for finish, I will say finish 1, pen up. Okay, because I don't need about that starting line, and when I reach that thing, I need to put pen down and start painting. So that is right here. Finish 1, pen down. So I'm not inventing this. You have this in documentation, like these methods. These are not custom methods. You have that as a part of Turtle. And you don't need to provide any parameters here, arguments, whatever you like, call it, because they are very, very simple, very dedicated methods. So let me test that. Right. Oh, okay, cool. So now we need to do same stuff for right target. Right, let me copy paste this down there, and this one will be F2. Oops, F2, and we actually need to change appropriate coordinates. So coordinates will be like a 300. Okay. And again, we are going in upper part of coordinate system, because when you're using Turtle, coordinate system is in center. So we are going here, and that is plus 300, plus 300. Right. So F5 to test application. Okay, we have something to work with. So let me think now. We will create main method that will use for loop to get here, and to do that we need to use a random module to have like incremental steps, but not same steps, because that's not the game, then that's stupidity. So you need that element of randomness. So let me do that in a source code. Like here I'm going to say import random module, because in here we have a range method to generate random numbers. Right, well, obviously, guys. Okay, so let me have some kind of separation here, and we're gonna create method like a main or game, whatever you're gonna call it, and we're gonna use for loop, like for x in range. You can also use while loop here, but for x in range means you have a limit number of steps. For example, if I say 200, maybe that will be enough. I don't know, I need to practice with this, don't worry about that. So now we need to push both of these turtles that we have here for specific number of pixels forward. Well, we know that from a couple of last tutorials. We're gonna do that with a T1, because that's the name of turtle, and we're gonna use FD, which means forward. So now if you say like just 1 pixel, so this is like a constant pixel, the thing will work, but the result will be same. So also we're gonna push turtle number 2 in that way. So this is just testing, okay guys, don't worry, we're gonna operate with random numbers. Now it's not enough to have function, we need to activate. So main, and hopefully something's gonna happen. Oh, right, oh yeah, but they are rolling like in a constant way. Right, so let me think what now. Obviously I need to boost this like a line, imaginary line, up till target. So I will use like a 400 pixels here, let's say, and now we're gonna play around with random numbers. So module is random and method is around range. So for example, when you use here 5 pixels, I mean 5 as a number, then we will have pixels here from 0 to 5 randomly. Right, so also I'm gonna put that thing for turtle number 2, and hopefully everything will be fine. So let me see what's up. Maybe that will be too much. Alright, so we have a race. Okay. Okay, who will be first? I don't know. Oh, oh, they are off the screen. Right, so let me see what I can do. Well, I'm gonna lower down number of possibilities, and let me press F5 here to see what's up. And of course you can boost both of these turtles with the speed 0, which means fastest speed. But let me just check what's happening. What is the reach here? No, so I'm gonna say 600 here. Okay, and let's change the shape of turtle when we start rolling, like how bigger turtles are. So T1 shape size will be 5 and 5 and 5. You have that in documentation and previous tutorials. And also same stuff for turtle number 2. And let's run that thing. Okay, come on. All right, here we are. And they're kind of slow. Very, very slow. But let me see what about that reach. Oh man, it's so slow. We're gonna speed it up. But just give me some kind of result. So apparently yellow is a winning. Maybe the red one will reach. You can play this game with your friends, you know, you can bet on something. Right, we have only just 2 turtles, but you can experiment with more. Okay, so we have reached that target, and obviously this guy is a winner, slight winner here. So let me see what I can do now. Right, speed. Let me change that here for turtle 1. Speed will be 0, which is fastest, and that is replicated to turtle 2. Let me see, do I have any difference? Well, maybe. Yeah, slight difference. And we see that slight difference because a very low number of pixels. But anyway, the things are working. So the question is, well, how to see who is winning here, like with some kind of helping lines? Well, I'm gonna pen down probably, remove that thing. So let me just see what's happening. In this case, who is now winning? Oh, so red one. So let me have that like a line. Let me see. I'm gonna comment this out. And let me, oops, what I did here. I'm gonna copy paste this couple of times. Where? Well, here, and also here and here, just to see what kind of lines I have. Okay, we have some kind of markings. Right, guys, so now we will at least have like a look in a part of the turtle that is winning or not winning. Yeah, there are better ways and algorithms and stuff like that, but I need to sit, you know, for the next 20 minutes and think about how to do that in source code, which is kind of boring. So let me see how to do that like visually. I mean, obviously we do have these circles, but right. So yeah, now you can use this like a marker who is winning. Yeah, something like that. And what if we have bigger turtles? Well, then what? Where I was... Okay, circle 40. And these guys will probably be bigger. Well, let's use 50. Maybe that will be nice. 50? Right. Alright. Well, that's... Oh, we are talking about circles. And I was thinking about turtles. Just a second, I will change that too. Well, actually, let me change that momentarily. Where to change that at the first place? Just a second. Right here. I'm gonna say 15 for a size of turtles and for radiuses for them, like for edges. 15, maybe that's too much. Oh, these guys are big. Let me see. Yeah, you can play around with this. You can do all kind of experiments. But they are slow, so what to do? Anyway, the program is working. So you can use it, practice, do whatever you like. You know, guys, what will be very interesting? Remember my tutorials about sockets and networking and stuff? So maybe you can create multiplayer game for turtles. Oh, they are going somewhere. Right, so who is winning now? Well, this one, because I have a bigger part here, visually. So these lines are kind of helping. Well, definitely I need to lower a line, like size of turtles. So I was talking about multiplayer socket networking turtle game, whatever. You have 5, I think, tutorials on sockets in my playlist for Python, so maybe you can play around with your friends and stuff like that. Yeah, I know you probably need 2 hours to do that and do all kind of testing, but if you have a little bit of time and nerves, then you can try that. Okay, this was very long tutorial and definitely the turtles are working, so I'm gonna pretty much end up here. Let me change those to original 20. And yeah, guys, that's pretty much it. If you like more turtles, then just generate them, you know, on different locations, like here, here, here. And here's a thing before I am done. I'm kind of cheating in this tutorial, you know, because Turtle 1 will always have some kind of slight advantage. First we are creating that thing, and then we are cloning number 2, and then we are setting like positions first for T1, and then I'm creating down there, you know, for loop operations first with the first turtle. So this is kind of slight cheating. I mean, actually it is cheating. So what you can do here, well, you can slightly boost, I don't know, the size of a first or of a second turtle to compensate, or you can have here like a 5 pixels, but that is definitely cheating, guys. So yeah, you can play around with a couple of like turtles more, and that will lower down that cheating. Right. Obviously you can upgrade this, but I just don't have nerves to do that right now. And the source code, you probably want to see that fully here. So let me see what I can do. I'm gonna, where is that thing? Right, so use 14 here, maybe, oh, right, so you can see that on your screen. And now you can copy paste it, do whatever you like with that. Okay, guys, a long tutorial. Thank you for watching as always, and see you next one. Hello guys, see this situation from last time? We basically need to visually check which one of these is a winner. And that is kind of bad because we are not that precise. So the question is how to do that thing programmatically. Because the whole purpose of programming is to pass jobs to machine, so we don't need to think. Okay, so we are forgetting about visual checks, visual confirmation, and we're going to devise some kind of, let's say, algorithm. So if you're thinking that that algorithm need to be complicated, like some collision detection with a target which is actually a circle, then you're wrong. Why? Because here, to tell turtle state, we have very nice position method on that specific turtle that will return x and y coordinate for us, so we can do all kind of manipulation and checking and stuff like that. So let's first print position of turtle 1 just to practice, and then a little bit later we're gonna devise that like a check or algorithm. Algorithm, very simple one. Right, so the target will be turtle 1, and we're going to use position method, and of course this method you don't need to pass any kind of arguments to it, because this stuff will just return result to you, so no arguments. Okay, so save and F5, and nothing's gonna happen here like in this part of a shell, because we are not doing anything with the data that we have at our disposal. So let's use it, well, at least through simple printing. And now we will get those coordinates. F5, and you will see a lot of numbers here. Hopefully. There you go. So the question is how to check these things. Okay, let's answer that question, but first I'm gonna to lower down the size of these turtles because it's easier to work with smaller objects when you are messing around with coordinates. Well, this is at least what I think about that. And sure, of course, you can also check position for turtle number 2 or any other turtle you have on a screen if you have 5 or 6 of them, if you have bigger game. Right, so I will not delete this size of turtles, I will just, pull it off this service with comments, one-liners. So let's check that, and now we will have a lot of automatic positions on a screen for both of these guys. There you go. Okay, scary stuff, but don't worry too much, because you just need to care about one pixel. Here, the starting point of your target, which is basically circle. So you don't need to check for every pixel on this imaginary line. Just this one pixel is enough to tell you the state of winners here for both of these. So don't worry about that. Right. So the question is, well, what is that pixel? So see this stuff? This is starting point of our circles, like beginning of coordinate system for that target. So we actually have our target. So when we check against 300, we will have a winner. Okay, so let's do that down there. We're gonna do that with if statement, like if T1 position equals to 300, then we are going to do something, but it will be very nice if we put this into dedicated brackets because it's easier on eyes. Well, at least that's what I think. And the problem here will be, well, let me explain. If position is 300, then we are going to print like turtle 1 wins. 1 wins. But actually we are creating error here, so let me explain what's gonna happen. So we will have smaller like turtles, but we will not get usable result, guys, because we are checking about both of these coordinates. This thing will return us x and y, but what we need is just y. So how to get that y? Well, here we are going to use positions, basically angle brackets. So when you say angle brackets, that means you can extract those positions, and x will be position 0 and y will be at position 1. So when you say 1, then you are actually checking against y, vertical coordinate. And let's run this stuff and let's see what's up. And this will be very slow, but guys, maybe we will get correct result or maybe not, and I'm going to explain why. Let me just see what's gonna happen. Maybe we'll get it, maybe not. Here. So yeah, turtle 1 wins, but here's a problem. See these like steps here? We're talking about from 0 to 3 steps. So this 300 equals to exactly 300 will work only if you are moving your turtles by 1 pixel. But when you do that, you don't have that element of randomness. So basically you are destroying the whole purpose of your game. So you must have some bigger number here from 1, because you need that randomness. So how to solve that thing? Well, here you will not check against 300 exactly, you're gonna check against 300 and more, because our steps here, pixel steps, can be smaller or bigger randomly. So there is a chance that we are going to miss that 300. So how to do that? Well, we are just going to say more or equal to 300. And it will be very nice if we do the same check for turtle number 2. So let me copy paste a little bit. I'm gonna grab this and I'm gonna put it down there, and we're gonna use elif in this case, and we are checking for turtle 2 here, and result must be turtle 2 wins. So let me see, will that work? And this is kind of slow, so I need a bigger steps here. like we're gonna use 10 possible jumps, so the jumps will be random up till 10, so the turtle will be faster. Turtles, hopefully. Okay, they are faster, but let me see. Okay, so turtle 2 wins and they are off the screen, and then turtle 1. So this will not work. So what we need to do here is when turtle 1 wins, we will break, and when turtle 2 wins, we will also break from execution. So let me see, will this work? Probably it will. Hopefully. Okay, turtle 2 wins. So this is nice, and let me find situation for turtle 1, for red one. Hopefully. Alright. No, why the turtle 2 wins? Well, is it really winning? Oh, I can't do zoom this. Oh yeah, it is winning. So the spaces between arm of turtle and for a red one is smaller than this space. Right, so turtle 2 definitely wins. I need to confirm result, correct result, a visual for turtle 1 to make sure that everything is cool. Okay, yeah, that's it. So everything works. But I need to make sure, so at least one more time. Come on. Yeah, that's it. We have solution. So that's it, guys. This is how in couple of lines of code, in 6 lines of code, you have solution to answer to question who is winning here. And of course, if you have like a bigger number of turtles, then you can use some kind of like a list for all these turtles, because manually typing T1, T2, T3 is kinda, well, boring, so you can devise this source to be a little bit complicated with some kind of automation and automatization, how to say this in English. Anyway, guys, now you have extremely nice base to play with more turtles if you like. And I don't want to go to like more turtles than 2 because the source code will be big. And if this is the first time for you watching these tutorials, then up till now I have 11 tutorials that you can check, and then if you don't understand this, after 11 tutorials you will be able to grasp the code. And don't worry, guys, if this is your first time, this is just a turtle model, so it is very nice to grasp all kind of movement in Python modules, well, at least in graphical one, and that will be extremely helpful a little bit later when you start with some kind of serious game development, let's say. Right, I'm gonna shut up, and as always, thank you for watching, and see you next tutorial.